So increasing marginal returns. This is sort of an introduction to something that's going to be important when we talk about economies of scale. But right now, suffice it to say, this is a capturing of the reality that if you're producing a certain amount with one worker and then you hire a second, you may double your output or you might not. If you then hire a third, your output might triple. But at some point, as you hire more and more workers, the return to your output is going to go down. But it might go up for a while. So increasing marginal returns means that the more people you're hiring, the more you're getting. If you're a mover, for example, if you only have one person working for your moving company, it's going to take them a long time to move things. You hire a second person, your productivity in terms of the time spent it takes to move everybody's furniture goes way up. It more than doubles. Get a third person, it might more than triple. But eventually, you're going to have a lot of people bumping into each other and getting into everybody's way, in which case we have decreasing or diminishing marginal returns. In all production plans, you're going to have points in which your marginal returns are going up, but then eventually they're going to start going down. And we're also going to see this in terms of marginal costs. When we get to that, they're going to go down for a little bit, but for the most part, they're going to go up. So we have these definitions in mind. We're ready to deploy them as needed when we get into economies of scale. But let's get back into features of the short run. And one of the main features of the short run is, well, if you're in the short run, you have fixed costs. Again, fixed costs mean that the most important thing to keep in mind about fixed costs is quantity. On this graph, you have low quantities here, medium quantities, high quantities. We know how to read graphs, I certainly hope at this point. What the essence of a total fixed cost is that no matter what your quantity, your total cost, the fixed part, doesn't change. It's this flat line. It's the same. Your costs are the same. No matter how much you make, your fixed costs, they're not changing. It's the exact same amount. Again, go back to the factory example. If you had to borrow a certain amount of money to open up that factory and you're paying that money back over a certain period of time, you have a loan contract that is probably not based on any of the volume you're doing. So if you bought that factory, you have to pay back that loan, and it's the same exact amount that you're paying back, whether you decide I'm not going to run the business, never mind, and you never operate the factory, or if you're making a ton of stuff and you need to open another factory. Your payment doesn't change no matter what your volume. That is the essence. That's the most important aspect of fixed costs. It doesn't matter what your quantities are. So they're costs that do not change with the amount of output produced. Variable costs, meanwhile, they do change with the quantity produced. Costs that change with the amount of output produced. As you produce more, your variable costs are going to go up. As you produce less, they're going to go down. So the factory is a fixed cost. Doesn't matter what you produce, you're going to have to pay the same amount there. But what about your energy? If you turn on your machines, your energy bill is going to go up. The longer those machines are on, the higher your energy bill is going to be. The more stuff you make, the longer you need your machines to be on, the higher your energy bill goes. So your variable cost, your energy bill is a variable cost. The way this looks graphically, related to quantity, again, both variable and fixed costs, the distinction has to do with what happens to them as quantity changes. Quantity goes up, fixed cost doesn't change. It doesn't matter what the quantity is. Quantity 0, quantity gazillion. Your fixed costs are exactly the same. But your variable costs, those go up. And all they do is go up. If you make nothing, your variable costs are 0. You don't need to spend any energy if you're not producing. If everything is off, you have an energy bill of 0. That's not necessarily the case, but to simplify, we'll assume it is. You don't need to pay any of your workers. Workers are a variable cost. You hire more or you pay more hours, as you produce more. If you're not making anything, you're not paying anybody. We're assuming for simplicity again that we don't have salary arrangements that you have to pay no matter what. If you want to complicate things like that, you can put that in fixed costs. But most models, we just figure you pay someone for a certain number of hours worked. The more hours they work, the more you're getting, the more you're making, but your costs are going up with each additional unit. Your variable costs just keep on rising. That's the difference between fixed costs and variable costs. It all has to do with what happens as quantity goes up. As quantity goes up, variable costs go up. As quantity goes up, fixed costs, they don't care. Fixed costs are the apathetic one. You can almost think of it that way, while variable costs are very sensitive to changes in quantity. So total costs, we had this in our profit equation. Certainly in the accounting profit, your total costs, well, they are all your costs. It's pretty simple, but you're going to need to solve problems where you're trying to derive your total costs when you're not given your total costs, but you're given fixed and variable costs. Just add those up. Your fixed and variable costs added up are your total costs. Fixed cost plus variable cost equals total cost. Pretty simple, but again, for a lot of problems, you're going to be missing one of them, so you use the beautiful magic of algebra to figure out what the other one is. So, total costs graphically. You notice some similarities right away between total costs and total variable costs, perhaps. The curve has the same exact shape. As your quantity goes up, your total costs have to rise. Have to, because your total costs include some variable costs. But notice, total costs are always above variable costs. That's because total costs are adding this bit in. So your total costs are always going to be above variable costs. Always, always. Because they equal all of your variable costs plus more stuff. So total cost is always going to be higher. Notice also where total costs start. If your output is 0, your variable costs are 0. It's not a variable cost if it's a non-zero amount at 0 production. But your fixed costs are exactly where they are when you make that 80 gazillionth unit of output. So your total costs start at your fixed costs. Fixed cost plus variable cost is total cost. If variable cost is equal to 0, then total cost equals fixed cost. Going back to this equation, at output levels, if your output level is 0, your total variable cost is 0, so total cost is just total fixed cost. And that's represented on the graph here, where total cost starts, where fixed cost starts. And then as you add in variable costs, it's going to go up by the amount of variable costs that you're adding in. And it's going to keep going up away from the fixed cost curve, but it starts at that higher point because it includes your fixed costs. Now, average fixed cost. Why would we want to know the average fixed and average variable and average total cost? Well, this is going to become important when we look at the revenues you're bringing in, the prices you're charging, and how much output you want to make. And we're considering the fact that our marginal costs are just going to keep rising over time. It costs more to make more. But we want to know on average how much is it costing in order to relate it to price to get our optimal consumption amounts. But first we need to understand what average fixed cost is, and average variable cost, and average total cost. And happily, these aren't that complicated. It's just your total fixed cost, which is just your fixed cost, and you divide it by your output level. Average fixed cost is total fixed cost divided by output. As output goes up, fixed cost won't change. But your average fixed cost does change in a very important way. And we'll see that on the graph. Your total fixed cost is just a straight line. The cost doesn't change no matter the quantity. But if your costs aren't changing as quantities rise, your average fixed cost is going down. This is a very important thing to keep in mind when we get back into economies of scale that basically say higher levels of production, where you have more expensive equipment, more factories, whatever, that you can use to produce at higher levels, your overall average costs are going to be lower as you produce at higher levels. up to a certain point, because you are spreading those costs out over higher quantities. The average fixed cost curve, wherever it starts, it always goes down from there. Always goes down. If you're going to have a large scale production, you need to make sure you're producing a lot. Otherwise, your average fixed cost is going to be higher. This is always going down. It never comes back up. It never reaches zero, but it never comes back up. Let's look at the equation to see why. Total fixed, it's fixed. It doesn't move. Whatever number this is, if it's 100, if it's 1,000, it stays there. So let's say it's 100. Your fixed costs are 100, doesn't budge. This is always equal to 100. At quantity 0, this is still 100. We're just going to define it as still 100. Quantity 1, this is 100. Your average fixed cost is 100. Quantity 2, this is now 50. Well, this is still 100, but this is 50. As this number goes up, average fixed cost goes down. The higher quantity goes, the lower this goes. This does not change, but this goes up. You're getting closer to 0. But you never quite get to 0, do you? Because this is always equal to 100, and this is only getting bigger. So you're never going to reach the horizontal axis here, but you're also never going to start coming back up. Your average fixed cost will never, ever go back up. Again, this is very important when understanding economies of scale. If you're not making much output, if you're not selling much output, you don't want large economies of scale, things that'll be these big fixed costs. You want to avoid those. But if you're making a ton of stuff, then it's worth considering investing in the ability to produce a ton of stuff and get those average fixed costs falling over time. It doesn't seem very remarkable yet, perhaps, but as I said, when we get to economies of scale, it's going to be very important. Let's compare this to average variable costs, which again, mathematically, it's simple. Total variable cost divided by quantity, except the curve looks different. It goes down for a little bit, and then it starts going up. Why on earth would this be? Well, you have a straight line going up for total variable cost as quantity goes up, but what that curve didn't necessarily show is that, again, you can hire so many workers, they're bumping into each other, that you're not getting as much out of them. So as quantities go up, your variable costs are going to start rising. Your average variable costs are going to rise as your quantity goes up. At first, they're going to fall. They're going to reach a low point, and then they're going to start rising again. Average fixed cost always goes down. Average variable cost goes down for a bit, and then it starts going back up. Total variable cost always goes up as quantity goes up, but the degree of change is not going to be the same for every unit of output. That's why we don't have this steady decrease as in the case of average fixed cost. So average total cost, again, nice and simple. Your total cost over quantity is going to be your average total cost, and it's going to be the sum of your average fixed and average variable cost. Notice again, the average total cost curve is above the average variable cost curve at all points, but it has a similar shape. But notice they're further apart here than they are here, because here your fixed costs, your average fixed costs are really high. So they're making a big difference here. Your average total cost and variable costs have a big difference because your average fixed costs are high. But over here, as your average fixed cost gets closer to 0, it's not going to make a big difference between your average total and average variable cost. These two lines will never meet because this line is adding up these two values, and this will never be 0. But at some point, these become so close together that they're almost indistinguishable, but they start out far apart. So average total cost is always above average variable cost. On exams, these are not going to be labeled, but from their shape, you're going to need to know that the curve that goes down and up, but is on top is always the average total cost curve. The one below it that has a similar shape but is below is the average variable cost curve, and the one that always goes down is your average fixed cost curve. And then in the next video, we'll get into more parts to add to this very important graph. Make sure you understand this well.